I think it's important for you to hear some tips about Chapter 7 that I think you will find, one, helpful for your test, but also helpful for as we continue on and finish up chapters 8 through 12. So here's the first thing. When you read a problem, especially a free response, the one thing you want to ask yourself is the variable of interest that you're looking at, or the data they are giving you, is it categorical or is it quantitative? So remember, categorical data is when they give you a word answer like yes or no. Quantitative is they give you a numerical answer such as, how tall are you? What that means and why it's important is because of this. If something is categorical, that is a proportion. And that's where in Chapter 7 you're going to be dealing with P and P hat. If it's quantitative, that is when we talk about the means, and that's the X bar. So if you can first identify what type of variable it is, it's going to help you understand what type of mean and standard deviation do you find when they ask you to describe the distribution. So now let's look at describing a distribution. Now, whenever you're asked to describe the distribution, you want to refer back to Chapter 1 and don't forget your SOCs. This is very important. Our shape, center, and spread. So when we talk about the shape, this is where we are looking to see if it's normal or approximately normal. Our center, that's when we're talking about our mean. And then our spread, in our case, is going to be our standard deviation. Now, depending on how you talk about these three elements depends if your distribution was dealing with a categorical or quantitative variable, that is, if it's a proportion or if it's a mean. So let's address how you would handle these three for the two different types of variables. Now, if you have to talk about the shape of it, if in the free response question they actually say the distribution is normal, then you're fine. It's addressed already. However, if you plan on using normal CDF at any point in time, you must show that the distribution is approximately normal. Now, to do that for proportions, what you have to do is take n times p and show it's greater than or equal to 10, and its complement of n times 1 minus p is also greater than or equal to 10, where n is a sample size and p is your probability of success. Now, center, we know that mu of p hat for proportions is just equal to mu of the population that's given. And then the last one is spread. To do the spread for a proportion, this is where we're going to take the square root of p times 1 minus p all over the square root of n will give us our standard deviation. However, in order to actually create the standard deviation calculation, you have to check if independence exists. To check for independence, you must look and see if n is greater than or equal to 10 times little n. So remember, in this case, this stands for is the population greater than or equal to 10 times the sample size. Now, going forward, a lot of the problems aren't going to actually tell you the actual population size. You would just have to be logical and make sure that it makes reasonable sense. For example, if we sampled 30 students at our high school, that means we have to make sure that there's at least 300 students at the high school. Does that make logical sense? Yes, it would be fine. So do not forget to check the 10% condition in order to make the adjustment to get the standard deviation you need for this proportion. Now, for the means, or something X bar or quantitative, what that means for the shape, again, if the problem says that the distribution is normal, we're fine. If it's not, we have to try to see if something is approximately normal. In this case, what you're going to do is incite the central limit theorem. You do not have to state it as a central limit theorem, but all you need to do is check, does n, is it greater than or equal to 30? If the sample size is greater than or equal to 30, then you can assume it's approximately normal, which will allow you to use the normal CDF calculations. Now, the center calculation, if we need to find the mu of X bar, it's just the mu of the population given. The spread is going to be the sigma of X bar is going to be equal to sigma over the square root of n. Now, where n is our sample size. Again, this can only be calculated if independence has been checked. And the check for independence is the population greater than or equal to 10 times the sample size. Do not forget to check for independence whenever you compute a new standard deviation calculation. The information I just talked about is so foundational for when we move on to chapters 8 through 12. You're going to be checking for shape, center, and spread more than you care to when we move forward into the book. But it's very standard, it's very procedural, and it's pretty much the same thing most of the time with some slight changes. But hopefully this conversation helps you as you better prepare for your chapter 7 test.